We have a chart here describing a series of reactions and observations. Our task is to figure out what the chemicals involved in each step are. This is perhaps my favorite type of chemistry problems back when I was in grade school, but it is understandable that students might be overwhelmed, as if they were thrown into the wilderness for survival. But there always tends to be at least one obvious target to take down first. For example, the gas that produces a white precipitate in lime water. Lime water contains aqueous calcium hydroxide, and a common white precipitate involving calcium is calcium carbonate. Hence the obvious candidate here is carbon dioxide, which reacts with calcium ions in the presence of water to produce a white precipitate. And where do we get CO2 from? It sure doesn't exist in the sulfuric acid, so the only possibility is to have it in the powder mixture in the form of carbonate, which upon the addition of acid produces water and CO2. Outside of CO2, the powder mixture formed the transparent solution E. Apparently some metal exists in the original mixture, which did not react with the acid. So things like copper, silver, or gold come to mind. That the metal can be oxidated into a black powder is indicative, but the blue solution that it produces after oxidation and reacting with the dilute sulfuric acid is what confirms that the metal is actually copper. The solution of aqueous copper has a blue or azure appearance, whereas copper oxide is exactly a black powder as described. So now we're only left with one branch of the chart. The transparent solution that was separated from copper is treated with a small amount of aqueous ammonia. So ammonia is an alkaline gas. When dissolved in water, it snatches away the hydrogen ion from H2O and leaves behind a hydroxide ion. However, there are multiple metal ions that can form white precipitate with hydroxide, such as aluminum, magnesium, zinc, and even calcium. The more decisive information here is what follows. With continuous addition of aqueous ammonia, the white precipitate eventually disappears. For the regular metal ions taught in grade school, the ones behaving in such a way are aluminum and zinc. Both of their cations will form a white precipitate in the presence of hydroxide, but if the solution is alkaline enough, their precipitate would further react with the excessive hydroxide to form aluminate and zincate. However, this does not mean either of them can be the right answer. The only suspect that fits our description here is actually zinc. So this actually has something to do with the strength of acids and bases. In general, the products of an acid-base reaction will not be stronger in acidity or alkalinity than the reactants. But this topic is much more nuanced, so it's better if we save it for another day. For now, let's just rejoice that we have figured out A and B from the basic reactions and simple observations provided.